This is question number 8, exercise 7.1. It says a right triangle ABC, right angle at C. Right. So we can clearly see that there is a right angle C over here. That is, this is a right angle. See, that's given here. What else he says? He says that M is the midpoint of the hypotenuse AB. AB being the hypotenuse and this M be the midpoint. So these two. That means AM is equal to BM is the further information given. When you read further, you find that even DM is equal to DM is equal to CM. In the first part, what we have to prove is this triangle, that is triangle AMC is congruent to triangle BMD. So I'm stating the triangle here. The triangle AMC is this one. This triangle is AMC. And the other triangle that we need to prove is this, that is this one. So to prove these two triangles congruent, this part is very easy. As you can see here that we have this side is equal to this side. This side is equal to this side. And there's one vertically opposite angle. So you can prove this true triangle by SAS. So let me show it. So we'll consider the two triangles, a triangle AMC and the other triangle that is BMD. We have AM is equal to DM. We also have CM is equal to DM. These two information were given on the question. And as given, further we can write this angle that is AMC, this one, this angle AMC is equal to angle DMB. That is this one, right? These are vertically opposite angles. And you know, whenever two lines intersect, they form pair of vertically opposite angles and they are equal. So now we can say, therefore, the triangle that is AMC is congruent to the other triangle that is BMD, and it is congruent by side angle side. As you can see, the angle is included between the two sides. So this is how the first part can be proved. Now, coming to the next part, what we have to prove here that this angle, that is angle DBC is 90 degree. You have to prove this angle as 90 degree. For that, we are going to use this CPCT condition. We have proved these two triangles congruent, right? As we have proved this triangle congruent to this triangle. So from CPCT, that means when two triangles are congruent, then their corresponding angles are equal. So over here, we can write this angle 1 is equal to angle 2. Now, at this stage, many students think that from CPCT, this angle should be equal to this. Not exactly. When you look into this, A corresponds to B, and this is C corresponds to D. So from corresponding parts of congruent triangle, it is angle 1 is going to be angle 2. Need to be clear. Angle 1 should be equal to angle 2. Reason, as I said, it is from CPCT. So once these two angles are equal, look here that considering BC as the transversal, here these two lines are parallel. This line should be parallel to this line. Reason, we can see that these are alternate interior angles. Angle 1 and angle 2 are alternate. Look into this. These are alternate interior angles with respect to AC and BD. So we'll write here, but they are alternate interior angles with respect to AC and BD. So we can say, therefore, AC is parallel to BD. Now, why are we proving these two lines parallel? As we know that the co-interior angles are supplementary. So if I prove this line, if we prove this line being parallel to this one, and this being the transversal, BC being the transversal, can we say that this angle and this angle are their co-interior angles and they are supplementary? That means I can write here, I can clearly write here, that is angle B plus angle C is equal to 180 degree, and that's by co-interior angle, as co-interior angles. So since we know the value of this angle, that is C as 90, we simply replace this C with 90 degree, and therefore transposing this C on the other side, is 180 minus 90 is 90. So this is how the second part of this can be proved. Now coming to the second part, the third part, we have to prove two more triangles are congruent. And what are these? One is this, and the other is this one. We are going to prove these two triangles as congruent. Some overlapping regions are there. We are doing this. DBC congruent to ACB. So we'll consider these two triangles first. So we'll write in triangle. This is DBC and the other triangle, that is triangle ACB. We can write AC is equal to BD. Now, must be wondering how come AC is equal to BD, it is not given. Well, we have proved these two triangle congruent, right? We have already proved these two triangle congruent. So we can write these two sides equal, that is, these are corresponding parts of congruent triangle, right? These are corresponding parts of congruent triangle. So we can simply write CPCT, nothing else. CPCT, as we have already proved these two triangles congruent, right? So their parts will be equal. Further, we know that angle B and angle C, just now we proved each 90 degree. And BC being the common side, BCA is equal to CB, that is common. So now we can write, therefore, the triangle, that is triangle DBC is congruent to triangle ACB. And the reason will be, that is side angle side. That's the third part. Now in the final part, what we have to prove is the length of CM. CM is this much. CM, which is nothing but half of DC, right? CM is half of DC. As you know, M is the midpoint, right? So we can write CM as half of CD, right? But we need to prove CM as half of AB. Well, let's understand first. Let's set aside this first. We already know from CPCT that we can say here that AB is equal to, the length of AB is equal to CD. That's from CPCT. Let me explain you this again. We have proved few triangles congruent here. What were these? The triangle this I proved this triangle, right? And congruent to this one. We have proved these two triangle congruent. And as you know, when two triangles are congruent, we can write their corresponding side. That means this one and this one as equal. So we can write these two sides as equal. That's from CPCT. Now we need to prove CM as half of AB, but we know that CM is half of CD, as M being the midpoint of CD. And as from here, can I replace this CD with AB, as CD and AB are equal? That's how the fourth part can be proved.